Today, we're unpacking a mission that has seriously launched India into the big leagues of the global space industry. ISRO just pulled off a historic flight with its most powerful rocket, and believe me, the shockwaves are being felt all the way from Sriharikota to the US. So what makes this one mission so incredibly important? Well, let's get into it. Okay, right off the bat, let's just talk about the sheer scale here. The payload on this mission, it weighed in at a staggering 6,100 kilograms. That's 6.1 metric tons. It is, without a doubt, the heaviest thing ever lifted into orbit from India by an Indian rocket. This isn't just a small step up, it's a massive, massive leap in capability. So how they pull it off and what does it all mean for the future? In this explainer, we're going to cover the landmark launch itself, then we'll dig into the game-changing tech that made it all possible. We'll get a closer look at India's Bahubali rocket, unpack why this is such a huge commercial win, and see how it's paving the way for India's really ambitious future in space. All right, let's start with the main event. Picture this. From the Satish Dhawan Space Center in Sriharikota, the LVM3-M6 mission just roared to life, thundering into the sky carrying its record-breaking passenger. What a sight. Now, let's talk about why they did this. This wasn't just a test flight for show. No, this was a dedicated commercial launch for an American client, AST Spacemobile. The whole goal was to place their satellite with absolute pinpoint precision into a 520-kilometer-high low Earth orbit. And you know what? The rocket executed it flawlessly. And the satellite itself? It's an absolute marvel. The BlueBird Block-2 isn't just heavy. It's the largest commercial communication satellite ever sent into low Earth orbit. Once it unfurls, its antenna is a massive 223 square meters. And its mission? Its mission is to beam 4G and 5G broadband directly to regular, unmodified smartphones on the ground. The whole idea is to bring high-speed internet to literally billions of people who are still unconnected. But, the weight of the satellite is really only half the story here. The real technological leap forward on this mission was a crucial but often overlooked piece of hardware. So let's talk about these game-changing actuators. So what in the world is an electromechanical actuator, or EMA? Well, think of it like the muscle that steers the rocket. It's a really advanced system of electric motors and gears that precisely aims the rocket's nozzles to control its direction. And this is a huge, huge upgrade from the older hydraulic systems that were basically powered by fluid. And this comparison just lays it all out perfectly. The old hydraulic systems, they were heavy, super complex, and prone to leaks, which is a gigantic risk in rocketry. The new EMAs are lighter, way simpler, and far more reliable. Plus, they're basically plug-and-play, which makes testing and all the pre-launch checks so much easier and faster. And get this was the first time ISRO flew them on the LVM3's most powerful first-stage boosters. Hey, don't just take my word for it. A. Rajarajan, the director of the Vikram Sarabhai Space Center, actually put a number on the benefits. He said that just by switching to EMAs, they gained about 85 kilograms of payload capacity per stage. I mean, when you're trying to lift 6,100 kilos, every single gram counts. Okay, so now let's meet the vehicle that made all of this possible. It's affectionately known as Bahubali for its incredible strength, and its official name is the Launch Vehicle Mark III, or LVM-3. This is ISRO's heavy lift workhorse. So the LVM-3 is a three-stage rocket. It all starts with two massive S-200 solid boosters for that initial brute force liftoff. Then, the liquid-fueled L-110 core stage kicks in. And finally, you have the highly efficient C-25 cryogenic upper stage. This thing runs on super-chilled liquid hydrogen and oxygen, and it performs that delicate final push into the perfect orbit. And just to put its power into perspective for you, the LLVM-3 stands 43.5 meters tall and weighs about 640 tons at liftoff. It's designed to carry up to 10 tons to low Earth orbit, which is where this mission went, or about 4 tons to the much higher geosynchronous transfer orbit. This is a seriously, seriously capable machine. And maybe the most important number of all? Look at this track record. 9 launches attempted, 9 successful missions. That is a 100% reliability rate. In the high-stakes, high-risk world of space launches, that perfect record is arguably its most valuable asset. It's priceless. And that perfect record is absolutely crucial because this mission was way more than just a technical demonstration. It was a major statement on the world stage, a true global commercial triumph for India. See, this was the LVM-3's third fully commercial flight.
It was organized by a company called New Space India Limited, or NSIL, which is basically ISRO's commercial arm. Their whole job is to sell launches on Indian rockets to the rest of the world, and let me tell you, they are getting very, very good at it.
So here's where it gets really crucial. How does India stack up against the competition? Well, while rockets like SpaceX's Falcon 9 can lift more, just look at the cost. At an estimated $48 million, the LVM-3 offers an incredibly competitive price point for its payload class. For a lot of satellite operators out there, that combination of proven reliability and cost-effectiveness, well, that's the winning formula. The ISRO chairman, Dr. V. Narayanan, he drove this point home himself. He highlighted that this was the very first dedicated commercial launch for a U.S. customer, and he made sure to emphasize the vehicle's perfect reliability. This isn't just a launch, it's building a relationship with one of the biggest space markets in the entire world. And that brings us right to the future, because this single mission, as amazing as it is, it's not an endpoint. No, it's a critical stepping stone for India's increasingly ambitious plans in space. So why does this one mission matter so much for what's next? First, Gaganyaan. That's India's human spaceflight program. The successful test of these new EMA actuators is absolutely essential for making sure the rocket is safe enough to carry astronauts. Second, the quick 52-day turnaround time from the last LVM-3 launch shows ISRO can operate much faster. And third, a simpler, safer rocket is the foundation of any mission with people on board. And here's the incredible roadmap this mission helps make possible. We're talking uncrewed test flights with a humanoid robot in 2026, the first Indian astronauts in orbit by 2027, and then the really ambitious goal of an Indian space station by 2035. This is the path the LVM-3 is clearing right now. And the rocket itself isn't standing still. Not at all. ISRO is already working on the next generation of upgrades, a more powerful cryogenic upper stage, a brand new semi-cryogenic core stage, and the ability to restart its engines in space. Each of these will make the LVM-3 even more capable and even more competitive. Which leaves us with one final, really fascinating question. For decades, the heavy lift launch market was dominated by just a handful of nations. Now, India has firmly and affordably joined that club. So as ISRO continues to demonstrate this potent mix of capability, reliability, and cost-effectiveness, the question isn't if it will reshape the global space economy, but just